So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic motion. So this video will be about types of force and motion. So in short, to stay till the end of this video, as this is a very important one. So let's go ahead and start with the first question here. It says, a body can undergo the following types of motion except A. Translational, B. Random, C. Relative, D. Rotational. So guys, the answer to this question here is option C. A body can undergo the types of motion listed here, translational, random, and rotational motion, but it takes two bodies for relative motion to occur. So that's the answer to this question, option C. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 2. It says, which of the following quantities is not an example of force? We have A. Mass, B. Tension, C. Weight, D. Friction. So guys, all the other quantities here have their units in Newton apart from mass. So mass is in kilogram, and that's the only option here that is not a force. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 3. It says, the correct relationship between the displacement S of a particle initially at rest in a linear motion and the time t is. So guys, in order for us to sort this out, let's recall that the question here says the particle is initially at rest. So if we use the equation of motion, Newton's equation of motion, as S is equal to ut plus half at squared, it's going to be that since it's initially at rest, the initial velocity u will be 0, and that cancels out ut. So the equation becomes S is equal to half at squared. So if we make half a constant, that means S is equal to kt squared. So in that case, S varies as t squared. So option A becomes the answer to this question. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 4. It says, the quantity of motion of a body is its A. Velocity, B. Momentum, C. Displacement, D. Acceleration. So guys, the answer to this question is option B. Momentum. Momentum is actually the product of mass and velocity. That's the quantity of motion of a body. So guys, that's it for this question. Let's go ahead and consider the next question. So the next question we have here is question number 5. It says, an object of mass 5.0 kg moves with a velocity of 10 meters per second. Calculate its momentum. Alright, so guys, this is a very simple question for you to go about. Let's recall that momentum is the product of mass and velocity. So here we're given the mass already in the standard units and the velocity as well in the standard units. So we are just going to multiply the two, 5.0 kg times 10 meters per second, and that's 50 kilogram meter per second. So option A here is the answer to this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 6. It says, a plank is placed along the path on which a wheelbarrow containing sand is pushed at a construction site to prevent it from sticking, as illustrated in the diagram above. The large area of the plank prevents the wheelbarrow from getting stuck by A. Increasing the pressure on the ground, B. Increasing the reaction on the ground, C. Decreasing the weight on the ground, and D. Decreasing the pressure on the ground. So guys, the answer to this question is option A, that's to increase the pressure on the ground. So let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 7. It says, a man was moving round a circular path continuously for 4 minutes and covered the following distance in the times stated below. Alright, so guys, we've seen the table here with the times here. Which of the following statements is correct about the motion of the man? Alright, so guys, the option A says the velocity was uniform, B. the man was moving with uniform speed but non-uniform velocity. C, it was an instance of motion in which both speed and velocity are the same. D, the speed was changing constantly. So guys, looking at the table here, we'll see that in 1 minute, the man moved 200 meters. In 2 minutes, that's 400 meters. In 3 minutes, 600 meters. And in 4 minutes, 800 meters. So guys, if we check the ratio of all these, so we are going to have that 200 over 1 is 200, 400 over 2 is 200, 600 over 3 is 200, 800 over 4 is 200. So we'll see that the man was actually moving with constant speed, which means equal increase in distance covered at equal time interval. So guys, using this, actually initially here we have it stated in the question that the man was moving around a circular path. So the man was not moving in a specific direction. So in that case, it is not a uniform velocity. However, due to an equal increase in the distance covered in equal time interval, that's a uniform speed. So option B is the answer to this question. The man was moving with uniform speed but non-uniform velocity. So let's go ahead and consider the next question, guys. Alright, so the next question we have here is question number 8. It says, which of the velocity time graphs below correctly describes the motion of a body by a force that is equal to the frictional force acting on it? Alright, so guys, for this question here, the graph here that correctly describes the motion of a body by a force that is equal to the frictional force acting on it is the graph in option D here, because there won't be any acceleration, and as such, option D is the answer to this question. So when the force here is equal to the frictional force acting on this body, we will tend to have no motion from the body, and as such, there is no acceleration. So that's option D here. That's the graph in option D. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 9. It says, the types of motion which a cylindrical drum rolling down in an inclined plane undergoes are, we have A, rotational and translational, B, rotational and circular, C, rectilinear and circular, D, circular and translational. So guys, obviously the answer to this question is option A. A drum that is rolling down an inclined plane is undergoing a rotational motion as it rotates and rolls down. Then it's a translational motion because it's being displaced from one point to the other. So that's option A here, rotational and translational. So let's go ahead and consider the next and last question, guys. Alright guys, the next question here is question number 10 here, and it has a graph here. So the graph here is a velocity time graph, and the question here says, the diagram above illustrates the velocity time graph of the motion of a body. Calculate the total distance traveled by the body. Alright, so guys, for us to calculate the total distance traveled by the body here, we have to recall that in a velocity time graph, the area in a velocity time graph is the distance. So guys, in order to calculate the distance here, we are going to calculate the various area of the shapes that we have here. So basically we have shape A to be a trapezium, and then shape B to be a rectangle, and then shape C to be a triangle, particularly a right-angled triangle. So for this question, we're going to calculate the areas here and then add them together. So for a trapezium, we're going to have the area of a trapezium to be half into A plus B into H. So guys, in this question here, the A is this point from the velocity axis, that's from 0 to 10, that will be our A, whereas still on the velocity axis from 0 to 20 will be our B. So this line is A and the next line is B. So in that case, we are going to have our H to be on the time axis, that's the x-axis here. So that will be 5 here. So if we impute this into the equation, half into A plus B into H, we are going to have this equation to be that the area of the trapezium is equal to A plus B is actually equal to 30. So half of 30 is 15, and 15 times 5 is 75. So the next area we are going to calculate here is the area of the rectangle, that's this portion B. So that will be length times breadth. So we'll use the V axis as the length here and use the T axis as the breadth here for this. So that's 20 times 5. So remember that this is from 5 to 10, and 10 minus 5 is 5. So 20 times 5 is actually 100. So that's 100 here. So that is for that one. And then for the triangle, we have area of a right angle triangle to be half BH, or BH over 2. So the base here is actually 5, that's 15 minus 10 on the t-axis. Then the height here is 20, and then half BH is going to be 20 times 5, which is 100, then over 2, which is 50. So guys, if we add these three together, that will give us 75 plus 100 plus 50. So that will be 225, guys. So option B is the answer to this question. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below, and we're sure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. And thank you for watching this video. See you on the next one.